Welcome to The Explainer. Listen, the greatest jazz musicians in the world all have one thing in common. They don't just pick up an instrument and start playing randomly. No, they spend years mastering the rigid rules, the scales, the precise timing, so that when they finally get on stage, they can completely improvise. They know the rules so perfectly, they can break them creatively. And that is exactly the core concept for mastering the Cambridge Computer Science exams, specifically the 9618 syllabus. Today, we are cracking the code on a topic that pops up in virtually every single examination series: extended Ascii and Unicode character sets. But we aren't just reading from a textbook today. We are stepping directly into the minds of the examiners. To show you what I mean, imagine a real past paper question. We usually see two types of students attempting it. Let's call them Alex and Sam. Alex is the overloader. Alex dumps every raw computer science fact onto the page, bit sizes, history, you name it, but gives zero actual analysis. Then there's Sam. Sam rushes in, totally misses the command word in the question, and writes a one-sentence answer that completely misses the point. Today, we're going to take you from being an Alex or a Sam to being the strategist who knows exactly how to extract maximum marks.
Okay, let's dive into this with an urgent, flashing red light alert directly from the principal examiner reports. They explicitly state that the classic mistake is providing generic answers not specific to the question context. This is exactly what our student Alex does. It's so tempting, right? You spent hours memorizing that standard Ascii is 7-bit, extended is 8-bit, and Unicode can be 16 or 32-bit. You want to show off that hard-earned knowledge, so you dump it all on the page. But if the question is asking about a specific embedded system, or maybe a brand new global messaging app, and you just give a generic definition, you lose the marks. The examiners are practically begging us here. Always link every point to the given scenario. If you don't anchor your knowledge of character sets into the specific world of the question, you are leaving easy marks on the table.
And that brings us to the core academic benchmark for this entire syllabus area. The examiners are looking for analytical depth over superficial breadth. What does that actually mean for you when you're sitting in that dead silent exam hall? It means Cambridge requires logical, structured reasoning. They are looking for thinkers, not just memory banks. Our other student, Sam, struggles here. Sam might see the command word evaluate and just write, Unicode is better because it has more characters. That is superficial breadth. While knowing the basic facts is the price of admission, what actually gets you the A-star is your ability to deeply analyze why a specific character set is being used in a specific context and the exact ripple effect that choice has on the entire computational system.
To get you there, here is our agenda for today. 1. Core principles. 2. The technical methodology. 3. Top examiner warnings. And 4. Critical analysis requirements. Let's jump right in. Section 1. Core principles. Let's establish that fundamental knowledge base.
The foundation of any top-performing strategy is a bulletproof theoretical architecture. You need precise definitions, causal relationships, integration with other syllabus areas, and evidence-based reasoning. Now, to actually apply these principles, top students use something called the PEAL framework. That stands for Point, Evidence, Explanation, Link. When you write your answer, you state your main point about, say, Unicode. You provide evidence, like its 16-bit structure. You write an explanation of how that allows for a massive global character index. And finally, and this is where Alex usually fails, you link it back to the specific exam scenario, integrating it with other syllabus areas like network transmission speeds. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the strategy. Mastering this PEAL framework, especially that final link step, is your absolute secret weapon for higher marks.
So, the crucial takeaway here is this. Your ultimate goal is transferable conceptual understanding for unfamiliar contexts. The examiners are never going to ask you the exact same question you saw in your revision guide. They're going to invent a totally bizarre, brand new scenario. Maybe it's a database for an interplanetary rover. Who knows? But if you understand the core concepts of how character sets impact memory and processing, you can confidently apply your knowledge to literally anything they throw at you.
Moving right along to Section 2, the technical methodology. This is where we put the theory into practice. This is where the real transformation happens. We're turning those red pen marks into green check marks. It all comes down to the method mark strategy. This is the assessment practice where marks are awarded for demonstrating a systematic process, clear working, and logical progression, rather than just pulling a final answer out of thin air. Think about Sam, our student who rushes. Sam just writes down the final conclusion and skips the explanation, but Cambridge explicitly rewards the journey. If you're calculating the file size difference between an Ascii text file and a UTF-8 text file, you absolutely must show your step-by-step logic. The method itself is worth points, even if you make a tiny arithmetic error at the very end. Let's look at the exact blueprint, the 5-step procedural sequence to secure those method marks. First, deconstruct the question. Highlight the command word. Is it describe, explain, evaluate? Second, extract the relevant data about the character sets from the scenario. Third, select your analytical framework, like our trusty Peel method. Fourth, execute your answer with clear step-by-step notation so the examiner can follow your brainwaves. And fifth, present it all with the correct, precise terminology. Don't just say it takes up more space, say it requires a larger memory allocation. This is the exact blueprint that takes a messy, panicked response and turns it into a high-scoring masterclass.
Now, if the question involves practical algorithmic thinking, maybe you have to actually manipulate strings encoded in different character sets, the steps shift slightly. You need 1. Step-by-step decomposition of the problem, 2. Appropriate data structure selection, 3. Efficient code implementation, and 4. Rigorous testing. Following this exact 4-step progression proves to the examiner that you don't just know the theory, but you can actually engineer a solution.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get serious. Section 3, Top Examiner Warnings.
Welcome to our interactive workshop. I want you to actively participate here. We are going to look at these top 3 warnings straight from the examiners, and I want you to mentally scan them as a data challenge. Warning 1, confusing cause and effect. Warning 2, forgetting boundary conditions and edge cases. Warning 3, generic answers lacking specific context. Now, let's do challenge 2, find the flaw. Imagine our student Alex writes this sentence in the exam. Unicode is used because it has 16 bits, which means the text file will be exactly twice as large, making it the best choice. Can you spot the flaws? I'll give you a second. Okay, time's up. First, Alex confused cause and effect. Having 16 bits is the cause of the file size increase, but it's not the reason why Unicode is chosen. It's chosen to represent a wider array of characters. Second, they completely forgot edge cases, like variable length encoding in UTF-8, where it isn't always exactly twice as large. And third, they gave a totally generic conclusion. By actively identifying these flaws, you ensure you won't make them yourself.
If you struggle to hold all this technical data in your head under the pressure of the clock, here is a powerful memory hack. Use a visual story method to encode the concepts. Instead of just memorizing bullet points, create a movie in your mind. Imagine a tiny, rigid little cardboard box. That's standard 7-bit Ascii. You try to shove a brightly colored emoji into it, and the box literally explodes because the boundaries are too tight. So you have to upgrade to a massive, sprawling, futuristic warehouse. That's Unicode. It fixes everything, but, and here's the trade-off, it takes way longer to walk across the warehouse to find what you need, representing the processing overhead. So, for our third interactive challenge, speed writing. Next time you study, set a 30-second timer and try to write one perfect Peel paragraph using that exact visual story to explain the difference between the two sets. It works wonders.
Finally, let's bring it all together in Section 4, Critical Analysis Requirements.
This is your final system, the cheat sheet recap to guarantee top marks. To truly master critical analysis, you must demonstrate these 4 traits. You have to consider multiple solutions, you have to analyze the trade-offs, you must acknowledge the limitations of a system, and you have to justify your decisions with hard evidence. If you can decode the command words, apply the Peel framework we discussed, and run your answers through these 4 analytical checks, you are essentially building an unbreakable exam response. You are showing the examiner that you are a top-tier candidate.
And this brilliantly illustrates exactly how to analyze those trade-offs. When evaluating a character set for a specific scenario, use this matrix. Ask yourself, how does it impact time complexity, meaning the execution speed of the program? How does it impact space complexity, meaning the memory allocation and network bandwidth? And how does it handle edge cases, like boundary limits or unexpected legacy inputs? Balancing these 3 factors is the hallmark of a sophisticated A-star computer science student.
One last tip. When you get a comparative question, like comparing extended Ascii directly to Unicode, don't just list the differences. That is a classic trap. Comparative analysis demands that you identify both similarities and differences.
Use comparative connectives like whereas or similarly. Support each point with concrete evidence and weave them into a logical conclusion about which is better for the specific scenario provided.
We have covered an incredible amount of strategy today. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So, I want to leave you with this final, provocative question. How will you apply the visual story method to master unfamiliar contexts in your next practice paper? Think about that as you review your notes today. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.